Hi and welcome. I'm trying to learn electrical engineering. Today, resistors in series and parallel. And after we've done that, we're going to do stretching. And if you participate in the stretching, then it's what we're going to do. Resistors in series and parallel. If we need to join two resistors together in a circuit, there are only two ways in which this can be done. Okay, we want to have for some reason two resistors. And now there are two ways to do this. We seem to be able to do this in series, so first one resistor and then the second one, obvious, or in parallel. That is very interesting. It means we can have a current flowing or electricity flowing, and we just open it up to both sides and we will flow through both, and when we join them again to flow one. And the electricity, just like water, will go through both. Now, the water, if there's a resistance and actually blocked, it will then, at the end, eventually all flow through the other one. Now it would be interesting if a resistor would have the same effect. Probably not. It is not repelled. Water is not just resisted, it is repelled. If the water here is blocked, it flows through the other one completely. If there's a resistor and taking away all the current coming to here, it is not repelled and goes through the other one, it is just stopped and goes through the other. I think that is interesting. Multiple things of it. But the examples of water and current flow are different because water is repelled. Water is not annihilated. It stays there. What happens to the electricity in the resistor? And it's just interesting. Ohm's law is used to deduce the effective total resistance of each arrangement. I'm not so much in use with the word deduce. Ohm's law is used to deduce the effective total resistance of each arrangement. Ohm's law is used to take away the resistance, to calculate it. You will notice that in the above diagrams and following work, the letter I is used as a symbol for an electric current. Okay, I is an electric current. Later on you will find the letter G is used for capacity and cannot therefore be used to represent a current. Oh, C, it's a C. Is it a C or is it an omega? Okay, whatever. It's a C or an omega. It's a C. In series. Now the first example. Okay, if we have a series for the first resistor through the second resistor. Potential difference across ampere omega equals the potential difference across A and B plus B and C. Or whatever potential total amount lost, the whole total amount lost is what we have lost in the first resistor and the second resistor added together. That is the whole potential difference between here and here. That's okay. AC equals potential difference across AB plus BC. IR equals IR1 plus IR2. What is R? Resistor. The current at resistor, whatever is the current resistor which we have, the current which was resisted is the current resisted at resistor 1 and the current resisted at resistor 2 added. Notice that the same current I flows through each resistor in turn. I don't get it. So R equals R1 plus R2. Why should now the same current flow through the second one? It had lost the thing in the first. Whatever. In parallel. Maybe we're going to get it later. This time the current I divides into two parts. The current comes and it divides in two lanes. This time the current I divides into two parts. I1 and I2. One through each resistor. Here and here's no resistor. I equals I1 plus I2. VR equals VR1 plus VR2. But the potential difference across AB is the same for each. Oh, we are in more letters. But the potential difference across AB is the same for each resistor. AB. Okay, yes, it was taken away in both resistors the same amount because it went just through both lanes. Because we are not. Why should it now happen in series and parallel? These two results can be extended to apply to any number of resistors in series and parallel and apply to any network of resistors. Okay, whatever we had here, which we not understood, it applies for everything. Example 1. A resistor of 4. Now this is omega. That's playing for horses here before. Omega is a symbol for ohm. Is joined in series to a second resistor of 6 omega. What is the combined resistance? Yes, that makes sense. We're losing, it goes through. First resistor takes away 4 ohms, the second one 6 ohms, and we're losing 10 ohms. Example 2. The two resistors are now joined in a parallel. What is the new combined resistance? I divided by R equals 1 quarter plus 1/6. 1 IR equals 3 plus 2 divided by 12, that is 5 divided by 12. R equals 12 divided by 5, or 2 and a 2/2 5 ohms. Okay, we're having 4 and 6 ohms. And the first one takes away 4 ohms and the other one 6. This time the current divides into 2 parts. I said something with V equals R1, having 12. How do we come up with 12? 1/4 plus 1/6 has something to do with 5. Is it 5/12? Would that fit? Or it's on 24? No, it's on 12 actually. Or 24. Or 12? 3 and 2, yes, I think that's just 1 quarter plus 1/6 is 5/12. And 5/12 is 2.5. I don't get it. Let's do it on to example 3. But I think we understand the basics of it. It's just that we don't really get it, we will get it in our time. Just like, what is the combined resistance of a following arrangement of 4 resistors? So we're getting again 2 parallels, and we're losing here 2 ohms and 8 ohms. Is the current splitting exactly in the same way? We're having 2 ohms taken away here and 8 ohms here, and in series effectively give 10 ohms. Okay, the current which goes here through loses 10 ohms. Secondly, this pair are placed in parallel with a third resistor of 15 ohm, and what goes here through loses 15. That means we're losing current divided by resistor. What is we want? So let's say we're having a current of 10 and we're having a resistor of 5. Do we now mean that we're... I don't get it. I don't get the I divided by R. Where do we get the R here from? First the 2 ohms and 8 ohms resistance series effective 10, or then the other one takes 15 away. That makes sense. Thirdly, these 3 resistors are in series with a fourth resistor of 5 ohm. Hence the total difference is 6 plus 5, that is 11 ohms. How do we come up with 6 plus 5? How many count do we have from the beginning? What is the count we have? How do we know what the count is? We don't know how much is resistor, we don't know the count. Or do we know the count because we know the amount of ohm? We know there's 4 ohm taken away. A resistor of 4 ohm, of 4 omega. Omega is the symbol of ohm. Is joined in series to a second resistor of 6 ohm. What is the combined resistance? 10 ohms. Ohm's law is used to reduce the effective total resistance of each arrangement. You will notice that in the above diagrams and following work, the letter I is used as a symbol for an electric current. Later on you will find the letter C in use for capacity and cannot therefore be used to represent a current. First, the 2 ohms and 8 ohms resistors in series effectively give 10 ohms. Yes. Secondly, this pair 2 and 8 are placed in parallel with a third resistor of 15. So we're losing here 15 ohms. What goes here through? So we're losing 1/10 plus 1/15. Why? How do we know we're losing 1/10? Why 1 out of 10? I know it's 10 ohms, but why 1 out of 10? And that's the same as 530, that's 6 ohms. But why don't we lose now 6 ohms? What do we have left? And resistance 6 ohms. Why is resistance 6 ohms if it was here 10 and here 15? Okay, I don't get it. But I get the serious. it's here so much and here so much. But why no? I don't get it. There's not really an explanation for in parallel. This time the current I divides into two parts. It divides, okay. I1 and I2, one for each resistor. The total amount of I is I1 plus I2. What flows here through and here through is the current, is the total amount of the current. VR, what is V? And R. Equals V divided by the resistance 1. How do we come up with V? Plus V divided by R2. I don't know what V is. How do we know V? But the potential difference across A, B is the same for each sector. I divided by R equals I divided by R plus I divided by R2. These two results can be expanded to apply to anywhere. Example 1. Example 2. The two resistors are joined in a pair. What is when you combine resistors? I divided by R equals 1, 4, 1, 6. 1 takes 4 by 1, 6. 5, 12. The first one takes 1/4. Why? I divided by resistance. The current is 1 and resistance is 4 ohms. But how do we know that we have to calculate the total amount of current through the amount of ohms? Doesn't really make sense. Whatever. I think we're getting closer. We will get it over time. That was the electrical engineering part. We will do now the stretching. If you still participating in stretching, then it's better to ask. Like standing short of the fight apart, we're breathing in the outer. We've all got to the side. You can do that. Out to the other side. In and up. And arms down. Breathing in. And out when the head slides down the leg. And the other shoulder stays down. Breathing in. Out one. Arm over. Breathing down the ribcage. Out and back. Okay. Out one arm slides down. The other shoulder stays down. You can. Out, take one arm over. Breathing down the ribcage. Out and back. Feet are staying together. Breathe in, lift the arms up. The aeronautic aerobatic aerobatic. And breathe out one arm down. Breathe in, reach. Out and up. In, down. And now breathe in and reach. And breathe out and up. Arms down. Legs short of wide apart. Don't shoulder circles go back. Front and down. Back. Front and down and backwards. Now breathe in with the shoulders up. Breathe out, drop and down. In and up. Out and down. Breathe in with the arms up. And now reach always high with one hand. Pretend to take an apple hanging high on an apple branch. The point turn is a bit down and then turn it out. And now the arms to the side, breathe in. And then out over to one side. In. And out. Okay. And out. In. And out with the knee onto the knees. The buffalo fighting is hang out. Breathe in. And over shoulder front. In and back. Out with the other front. In and back. Out in the front. In and back. Out in the front. In. And out we're hanging down, the Niagara Falls. Breathe in. And out over the one leg. Breathe in. Out over the other side. Hang it in. Out into the middle. And close the feet beside the original. Breathe in. And out. Again. The out comes slowly with her long back up. Make it top and backward shot. Legs will take apart and breathe in, not on. Then breathe out. Get in. Out. Get in. Out. Get in. Breathe in and close the legs. And breathe out. Let's go for stretching. I thank you very much, and until next time.